Hi guys, so following on from the lesson today, this video contains the final two examples that will enable you to complete exercise 5A of the textbook. We're looking at example 3 and then example 4. Please can you work through this, make notes of it in your exercise book as I go through, as this will help you to work through those questions as I just said. So, two forces P and Q, action and particle is shown. P has a magnitude of 10 newtons, which I've labelled there, and Q has a magnitude of 8 newtons, which I have labelled here. Work out the magnitude and direction of the resultant force. So what I'm going to need to do is I'm going to need to find the overall horizontal component and the overall vertical component, and then use that to find the magnitude of the resultant force. So if I look at force P, I have got the horizontal component here and the vertical component here. You can see my arrows to show the direction. So as I have shown you in the lesson, where I have got P, which is 10 newtons, this is my horizontal and this is my vertical. And my angle here is 45 degrees. This is the adjacent and this is the opposite. So my horizontal component which is my adjacent, I'm going to use cos theta equals adjacent over hypotenuse. Hypotenuse is 10, and therefore I'm going to have cos 45 is equal to my x component over 10, and therefore I get 10 cos 45 as my x, or my horizontal component. My vertical component is going to be sine 45 is opposite over hypotenuse. I'm going to call it y because it's going in the y direction, over 10, multiply both sides by 10, and that gets me 10 sine 45. As the more practice you do, the more practice you get from doing different questions, you will be able to just identify this straight away. And going through the video, I am going to go straight to these, but this line of working will help you initially setting out your triangle, your right angle triangle for your force, to be able to see if you're looking for the adjacent or the hypotenuse. So that's for force P. Then for force Q, I have got my horizontal component here in that direction, and then my vertical component here going down. So because it's going down, I am going to take the negative value. So again, horizontal component if I need a little triangle to help me out here, I'm going to have that, and that. That's 8 newtons, that's Q. This is my opposite, and that's my adjacent again. That's my angle 30 and my right angle. So horizontal component is my adjacent, so I need to use cos, so it's going to be 8 cos 30, and my vertical component is going to be 8 sine 30. So now I have got those, my resultant force is going to be those components, those particular parts of the components added together. So if I look at the horizontal component, the overall horizontal component for the resultant force is going to be 10 cos 45 add 8 cos 30. So I can work this out using my calculator. 10 cos 45 is 5 root 2 plus 8 cos 30, which is 4 root 3. So I know my resultant force, the horizontal component for the resultant force is 5 root 2 plus 4 root 3. And then I need to do the same, but for the vertical component of the resultant force. So I'm going to have 8 cos, no I'm not, 10 sine 45 and then remember the vertical component here, it was going down, so I needed to take the negative value. I forgot to put that in there. So I've got negative sine 8 sine 30, so take away 8 sine 30, 10 sine 45 gets me 5 root 2. Where's my blue pen? And then 8 sine 30 is 4, because sine 30 is a half, just to prove it to you there. So 5 root 2 minus 4. So now what I've got is a horizontal component for my resultant force and a vertical component. So I have got this horizontal component, 5 root 2 plus 4 root 3. Vertical component, root 2 minus 4, and therefore my resultant force is going to be the magnitude of this squared plus this squared and square rooted, because I'm using that Pythagoras' theorem to do that. So I'm going to have this squared, so 5 root 2 plus 4 root 3 all squared, plus 5 root 2 minus 4 all squared. I'm just going to call it r, as for my resultant force, as r squared. Type this into the calculator, so 5 root 2, I should put brackets, 5 root 2 plus 4 root 3, oh gosh, no, that's gone wrong, 5 root 2 plus, there we go, 4 root 3 all squared, plus 5 root 2 minus 4, whoops, oh my gosh, my typing in, I'm so sorry about this, all squared, let's just check I got that right, yeah, gets me that number there, so 205.4110472 is r squared. The square root of that answer is going to get me my resultant force, so my resultant force is the square root of that, which is 14.3 newtons to 3 significant figures. Okay, I need to find the direction. The question asked me to find the magnitude, which is what I've done, and to also find the direction of the resultant force. So, looking at this triangle that I've got here, the direction is going to be the angle at which this force is going in. So all I'm going to do is I'm going to use the opposite, and I'm going to use the adjacent. Tan theta is opposite over adjacent. So tan theta is my opposite, 5 root 2 minus 4, over my adjacent, 5 root 2 plus 4 root 3. Theta is the inverse tan or arctan of that answer to what that's going to be on my calculator. That's what I'm going to type in a second, and then work it out. So inverse tan, put the fraction in, 5 root 2 minus 4 over 5 root 2 plus 4 root 3, close the bracket, whoopsie, close that bracket, and I get 12.37. And therefore the magnitude of the resultant vector is, resultant force, sorry, is 14.3 newtons, with the direction of 12.4 degrees. So that's that first example. The second example I have got for you is this one. 3 forces act upon a particle as shown, particle being this in the middle. Given that the particle is in equilibrium, calculate the magnitude of P. So P is here. Now I've got 2 unknowns here, which suggests I'm probably going to need to use simultaneous equations. So what I'm going to do is I'm going to look at my horizontal components and my vertical components and use them somehow to work out what the value of P is going to be. So when it's in equilibrium, we know that it's not moving anywhere. It's not moving left, or it's not moving right, it's not moving up, it's not moving down. It's not moving in any direction, and therefore we know that the forces pulling it, I suppose, to the left is equal to the forces pulling it to the right. The forces pulling it up is equal to the forces pulling it down. So that's what I'm going to use to do that. So let's work out what the horizontal and vertical components are for each of the forces. So this one is going to be, where's my pink pen for my vertical component? So left and up, right and up, and then this one's going to be left and down. Okay, so I have got here, this is going to be 140 cos, because it's my adjacent, 45. This is my opposite, so it's going to be 140 sine 45. My upwards here is my opposite, so that is going to be 100 sine 30. And this horizontal component for the 100 newtons, what I'm going to do is I'm just going to draw an arrow there to say for this one is going to be 100. It's the adjacent I'm looking for, so cos 30. Slightly messy, I probably should draw them as 3 separate triangles, but for quick and ease, hopefully this will just have to do. So for P, we don't know what the value is for the force, the magnitude of the force. So for this horizontal component, I'm going to call it P. It's the adjacent again, so cos theta. And then for my downwards force here is going to be P. It's the opposite, so sine theta. Now going back to what I said about the equilibrium, the left forces are going to equal the right forces, the up forces are going to equal the down forces. So let's look at my right forces. The forces that are going right are going to be 100 cos 30 plus P cos theta. That's both the forces turning or going in the right direction. Forces going in the left direction is therefore equal to 140 cos 45. What I'm going to do, because it's going to help me later on in the question, I'm going to rearrange this and just make the subject P cos theta. So to do that, I'm going to have to subtract 100 cos 30 from both sides. So I get 100 cos 45, probably put brackets around this, and then subtract the 100 cos 30. Same for my upwards and my downwards. My upwards forces are equal to my downwards forces, so 140 sine 45 plus 100 sine 30 is equal to P sine theta. So now I have got two equations in the form P cos theta and P sine theta. I know that sine theta over cos theta is equal to tan theta. So what I'm going to do to eliminate, I've got two variables, I've got variable P and variable theta in both of these, which is what's preventing me from working this out. I am going to divide P sine theta and that equation by P cos theta and that equation. So writing this out, I get P sine theta is 140 sine 45 plus 100 sine 30, and P cos theta is 140 cos 45 minus 100 cos 30. And as I said, I'm going to divide those equations by each other. So P sine theta divided by P cos theta, P divided by P is 1, sine theta divided by cos theta is going to get me tan theta. Now before I type all of this into my, actually no, I can type that straight in, I'm going to do that. So I'm going to do, there's two ways you can do this. You can type it all in and just make sure you type it in correctly, or you can work out what the values are for each of these, 140 sine 45 plus 100 sine 30, which is 53, 140 cos 45, etc. I'm just going to type it straight into the calculator. So 140 sine 45, close the bracket, plus 100 sine 30, close the bracket, over 140 cos 45, close bracket, minus 100 cos 30 and close the bracket. Here you get 12.023081999, and then to find theta I'm going to do inverse tan and get theta is inverse tan of that answer that's on my calculator. So the answer's still on my calculator, clear it off, shift tan, press the answer, it will do the inverse tan of that answer that was on the calculator, and you get 85.245466162. I'm going to say theta equals 85.2 degrees. Now it doesn't ask us for the value of theta, it asks us for the magnitude of P. And therefore, now I've got this theta value, I can just substitute it into either P cos theta equals this, so I would do this formula, or this number, divided by cos of that answer, or I could use the P sine theta and it would work exactly the same. It doesn't matter, I'm going to go with the P cos theta because it's at the top of the page there, it's easier for me to work with. So I'm going to say P is equal to this 140 cos 45 minus 100 cos 30, all divided by, because I'm going to divide both sides by cos theta, with the theta being that value that's on my calculator there, divided by cos of 85.245, etc. I'm going to show this, rather than writing theta in there, in my working, I'm going to make sure that I show that the number that I put in, I know what number to use, so I've got to show that in my working. P is equal to, I'm going to use this, clear that off. I'm going to have 140, I need a fraction, 140 cos 45 minus 100 cos 30, close the bracket, all divided by cos of the answer that was just on my calculator, and I get 149.5094202. So P is equal to 150 newtons to 3 significant figures. Whoops, sorry, there you go. And that is your final answer. The magnitude of P is going to be 150 newtons.